Hello, and welcome to today's lesson. We're going to start our work with right triangles, lesson 1, and we're going to focus today on the Pythagorean theorem. So by the end of this lesson, you'll be able to, given two legs of a right triangle, find the length of the hypotenuse. Given the length of one leg and the hypotenuse, find the length of the other leg. And then we'll also use the Pythagorean theorem to solve some real-world situations. Now, here's just some quick facts about Pythagoras and his society. I'm just going to scroll through this here quick if you want to pause and read some of these pieces, but some of the major facts, they work to prove the sum of the angles of a triangle is equal to two right angles, or 180 degrees. Okay, the theorem of Pythagoras, or we call it the Pythagorean theorem. Right angle triangle, the square on the hypotenuse is equal to the sum of the squares of the other two sides. They worked on constructing geometric figures, the discovery of irrational numbers, some things that we need to solve equations in other areas, and they weren't always right. You know, talking about the Earth being the center of the universe, which was very common back at those times. But now, when we look at the Pythagorean theorem, okay, this is something I'm just going to drill through. A squared plus b squared equals c squared. So what we look at is, when we're looking at a triangle, it's all about the area of the shape. So we have a squared, one area, b squared, the other area. We put those two areas together and we get the same area size as the c squared. Okay, the c is always the hypotenuse. The a and b sides, it doesn't matter which one's which. We can put those two in either place. Okay, so we can prove it in many ways, you know, building the shape, working through the different pieces overall. You know, here's just some ways how people have gone through to prove the Pythagorean theorem, a squared plus b squared, checking to make sure that it does equal c squared. Okay, so now actually working and using it to solve problems. Okay, we need our two leg lengths, or we need the hypotenuse. We always need 2 out of the 3 to be able to solve any situation, but we're building the equation every time based on the triangle that we see, and then it's just a matter of solving for the piece that we're looking for. So let's do a few examples here overall. So now we're trying to solve for the hypotenuse. We have the two legs, so 3 squared plus 4 squared equals x squared. 3 squared is 9, 4 squared is 16, x squared. So 9 plus 16 is 25, which is equal to x squared. To get the x value by itself, we have to square root both sides, and the square root of 25 is 5. So that's how we solve one of our most common problems. We have the two leg lengths, and we're trying to find the hypotenuse. Okay, the hypotenuse always is listed by itself. Okay, now, new triangle here in this situation. Okay, we're trying to find one of the legs. So we have x squared plus 5 squared equals 13 squared. So x squared plus 25 equals 169. We subtract 25 from both sides, and we get x squared equals 144. Okay, and we're always finishing these problems by doing the square root of both sides. The square root of x squared is x, and the square root of 144 is 12. Remember what we learned before. We always know that the two legs of a triangle are the two short sides of a triangle have to add up to be greater than the long side. So that's one thing you always want to keep in mind as you're going through this process. 3 plus 4 is 7. 7 is bigger than 5, which is the hypotenuse here. 5 plus 12 is 17. 17 is bigger than 13. Okay, so that helps us know, is our answer in the right realm? So now, if we're thinking about a circle, trying to find the radius, what we always want to do in any situation is build the triangle. Okay, so we're building our right triangle by dropping down. The distance of this base leg is our distance on the x-axis, or the 6. Okay, the distance for the second leg is our vertical distance, or the y. So we now have the two pieces of this triangle, and now we can solve for the radius of this circle. So radius squared equals leg 1 squared plus leg 2 squared. R squared equals 36 plus 64. R squared equals 100. And then we square root both sides to get our answer. Okay, so it's a very common process. There's only basically two types of problems we can ask in this scenario. We can either have you find the hypotenuse, or we can have you find a leg value. Okay, now, what are some other situations that we can give you? We can give you a scenario where we tell you about the diagonal of the square is 50 inches, and we want you to find the area of the square. So now what we need is we need the two side lengths, and since it's a square, the side lengths are equal, so we can give them both the same name. So we're going to still set up the Pythagorean theorem. S squared plus S squared equals 50 squared. Since there are two s squareds, we can actually say 2s squared equals 50 squared. And now this is where we go to the calculator to do a little bit of our calculations work. So we have 50 squared, okay, 2,500. So now we know that 2s squared equals 2,500. Okay, now we've got two things we have to get rid of, the multiplier and the exponent. The multiplier has to go first. We have to divide by 2, and then we get to square root to find our answer. Now, this isn't a perfect value, and that's going to happen. If the value is not perfect, you will be given some type of rounding rule within the assignment to work on and finish your entry for that problem. Okay, so we have our side length of 35.36. Okay, now what we also want to think about here is, what's the question asking? Always think back. The question here is actually asking for the area of the square. So the area of the square is side times side, and we actually have that right here. So could we do our side length and square it? Yes. Our answer would not be as exact, though, because if you're using s, you're using a rounded value instead of the s squared, which is the true area of that shape. Okay, what's the length of the diagonal of a square whose area is 81 centimeters? So remember, area of a square is length times width, or side times side. 81 equals s squared. So our side length is the square root of 81, which is 9. So if we want to find the diagonal measurement now, we have side of 9, and we're trying to find the diagonal, or d. So d squared equals 9 squared plus 9 squared. D squared equals 81 plus 81, which is 162. And then we're going to have to square root both sides to find what d equals. 162 square root 12.73. Rounding to 2 decimal places is usually the most common rounding that we do. Okay, and remember, that comes from finding the square root on both sides. Okay, now We can also work to find different measurements in shapes. Okay, how far is the throw from home base to second? Okay, if we know that a baseball diamond, each of the base lengths are equal to each other, so we have 90 feet, 90 feet, and then we're just trying to find x feet. Okay, notice this problem very similar to what we have here. Okay, so as we go through, we're going to see that this answer is going to be very similar to the previous answer that we have. To find the distance of the throw from home to second, 90 squared plus 90 squared equals x squared. We can go through and do our calculation. Okay, so 90 squared plus another 8100. Okay, we've got 16,200. Square root that, and we get 127.28 feet. Okay, so when you have a catcher throwing down, it definitely is taking a fair amount of distance. Okay, last one. How long must a ladder be in order to reach the roof? Okay, so if we know that the ladder slid out 8 feet, okay, we have a 25-foot distance. Okay, we're trying to find how long the ladder is. Okay, the ladder is the hypotenuse, so that's our c squared equals 8 squared plus 25 squared. C squared equals, and this is where we go to our calculation. We've got 25 squared plus 8 squared, which is 64. And then we have to square root that value to find the length of this ladder. And we have a length of 26.25 feet. So we've got our c squared is 689. Square root both sides to get our c value of 26.25. Okay, now we could finish this one up. Now the ladder has slid out further. Okay, the ladder height itself can't change. It's a set length, and we would just want to know how far up the house would it reach. And this is where we're always looking at, are we given the hypotenuse or are we trying to find the hypotenuse? So we have to do 26.25 squared, okay, which is our 689. Okay, we're going to minus 16 squared, and we've got 256, and then we square root that value to find out how far up the house it is going to reach. Okay, that concludes our lesson for today. Thank you, and we'll see you soon.